1.3 The arrangement of the electrons. During the early years of the 20th century, physicists made great strides in understanding the structure of the atom. These are some of the main landmarks. In 1913, Niels Bohr put forward the idea that the atom consisted of a tiny positive nucleus orbited by negatively charged electrons to form an atom like a tiny solar system. The electrons orbited in shells of fixed size, and the movement of electrons from one shell to the next explained how atoms absorbed and gave out light. This was the beginning of what is called the quantum theory. In 1926, Erwin Schrödinger, a mathematical physicist, worked out an equation that used the idea that electrons had some of the properties of waves as well as those of particles. This led to a theory called quantum mechanics, which can be used to predict the behavior of subatomic particles. And finally, in 1932, James Chadwick discovered the neutron. At the same time, chemists were developing their ideas about how electrons allowed atoms to bond together. One important contributor was the American Gilbert Lewis. He put forward the ideas that 1. The inertness of the noble gases was related to their having 4 outer shells of electrons. 2. Ions were formed by atoms losing or gaining electrons to attain 4 outer shells. And 3. Atoms could also bond by sharing electrons to form 4 outer shells. Lewis' theories are the basis of the modern understanding of chemical bonding and explain the formulae of many simple compounds using the idea that atoms tend to gain the stable electronic structure of the nearest noble gas. Early theories model the electron as a minute solid particle, but later theories suggest that you can also think of electrons as smeared out clouds of charge, so you can never say exactly where an electron is at any moment. You can merely state the probability that it can be found in a particular volume of space that has a particular shape. However, chemists still use different methods of the atom for different purposes. Dalton's model can still be used to explain the geometries of crystal. Bohr's model can be used for a simple model of an ionic and covalent bonding. The charge cloud idea is used for a more sophisticated explanation of bonding and the shapes of molecules. And the simple model of electrons orbiting in shells is useful for many purposes, particularly for working out bonding between atoms. You'll be familiar with the electrons diagram in this section from GCSE. They lead on to the more sophisticated models of electrons structure described in topic 1.5. However, they can still be useful, for example, in predicting and explaining the formulae of simple compounds and the shapes of molecules, as mentioned before. The first shell, which is closest to the nucleus, fills first, then the second, and so on. The number of electrons in each shell equals 2n squared, where n is the number of shells. So, the first shell holds up to 2 electrons, the second shell holds up to 8 electrons, and the third shell holds up to 18 electrons. If you know the number of protons in an atom, you can also know the number of electrons that it has. This is because the atom is neutral. You can therefore draw an electron diagram for any element. For example, carbon has 6 electrons. The 4 electrons in the outer shell are usually drawn spaced out around the atom. Sulfur has 16 electrons. It has 6 electrons in its outer shell. It helps when drawing bonding diagrams to space out the first 4, as in carbon, and then add the next 2 electrons to form pairs. You can also draw diagrams of ions, as long as you know the number of electrons. For example, a sodium atom, Na, has 11 electrons, but its ion has 10, so it has a positive charge, Na+. An oxygen atom has 8 electrons, but its ion has 10, so it has a negative charge, O2-. You can write electron diagrams in shorthand. First, write the number of electrons in each shell, starting with the inner shell and working outwards. And finally, separate each number by a comma. For carbon, you write 2,6, for sulfur 2,8,6, and for Na+, 2,8.